You are sitting in a room that feels stable. The walls do not move. The floor does not drift. Your body feels located in a single place, at a single moment, progressing forward in time, at a steady and unquestioned pace. Your memories sit behind you. Your expectations sit ahead of you. The present feels like a thin, moving edge between what no longer exists and what has not yet happened. This is how time is supposed to work. You assume the future is empty, not uncertain, not blurry, but genuinely non-existent. You believe tomorrow has not been written yet, that outcomes depend on choices, that events unfold one after another, and that the present moment is where reality is decided. But this sense of temporal safety rests on an assumption that has never been proven. Modern physics does not describe time as a flowing river. It does not require a moving present, and in some of its most successful models, the future is not something that gradually comes into being. It is already there, fixed in the same way the past is fixed, not as destiny or prophecy, but as structure. Experiments, equations, and mathematical necessities have forced physicists to confront a possibility that feels deeply wrong to human intuition, a possibility where nothing truly moves through time, where change is an illusion generated by perspective, where every moment you will ever experience already exists. This is not science fiction. This is not philosophical speculation detached from evidence. This is the quiet implication of theories that accurately predict how the universe behaves. The question is no longer whether time feels like it flows. The question is whether that feeling has anything to do with reality at all. You experience time as something that happens to you. Seconds arrive, moments pass, and the present feels like a special point that constantly updates. This assumption is so fundamental that you rarely notice it. Yet physics does not contain any equation that requires a moving now. Time appears in the mathematics as a dimension, not a process, and nothing inside those equations indicates that one moment is more real than another. You do not usually think of this as an assumption. It feels more like a direct observation. You feel time passing in your body. Your thoughts follow one another. Events appear to line up in a clear sequence: past, present, future, before, now, after. It feels impossible that this structure could be anything other than the basic framework of reality. But this feeling does not come from physics. It comes from how you experience information. When physicists write equations to describe the universe, they do not describe time as something that flows. They describe it as a coordinate, a label, a parameter that allows events to be ordered, compared, and related. The equations work whether time is treated as moving or not. In fact, they work best when it is not. There is no symbol in fundamental physics that stands for the present moment. No variable that marks now as special. No mathematical operation that advances the universe from one instant to the next. The laws do not say, this happens, then time moves forward, then this happens next. They describe entire relationships at once. This is deeply counterintuitive because your experience insists otherwise. You feel as though reality updates continuously, as if the universe refreshes itself every fraction of a second. But this sensation may not reflect how the universe operates. It may reflect how your mind samples reality. Consider how you perceive motion. When you watch an object move across a room, you do not see a continuous blur. You see a sequence of positions. Your brain stitches those positions into the experience of movement. The movement feels real, but it is constructed from static information processed over time. Time itself may be similar. What you call the present could be nothing more than the slice of reality your consciousness is currently accessing. Not a moment that objectively exists, but a perspective you occupy. From within that perspective, everything appears to be arriving, unfolding, becoming. From outside it, there may be no arrival at all. This is where discomfort begins. If the present is not a physical feature of the universe, then it is not something that travels. It does not advance. It does not carve the future out of nothingness. It is simply where you are. Physics allows for the possibility that all moments exist equally, that what you call the past still exists as part of the structure of space-time, that what you call the future exists in the same way, even if you cannot reach it or observe it. The idea that the future is unreal is not supported by any known physical law. It is a psychological intuition, not a scientific result. You may feel resistance to this, the sense that if the future already exists, something essential is lost. But physics does not concern itself with what feels essential. It concerns itself with what remains consistent, measurable, and predictive. And what remains, again and again, is the absence of a privileged now. This does not mean your experience is wrong. It means it may not be fundamental. The flow you feel could be a feature of consciousness moving through information, not of time itself moving through reality. If this is true, then the most basic structure you rely on to orient your life is not written into the universe. It is written into you. And that raises a quiet but unavoidable question. If time does not pass in the way you think it does, then what exactly is it that feels like it does? You intuitively separate time from space. You can move left or right freely, but you cannot move backward in time. Physics, however, does not respect this distinction. In its most precise descriptions, time is treated as another coordinate, similar to length or width, suggesting that past, present, and future are all equally embedded in the structure of reality. This difference between intuition and physics is not subtle. It sits at the foundation of how the universe is described. You experience space as something you move through, and time as something that happens to you. One feels navigable, the other feels imposed. Yet when physics attempts to describe reality at its most fundamental level, it removes this psychological divide entirely. In mathematics, a coordinate is not something that flows. It does not advance or retreat. It simply exists as part of a system used to locate events. When physicists assign a time coordinate to an event, they are not saying that the event emerged from the past or is heading toward the future. They are saying only where it is located within space-time. This shift in description changes everything. Once time is treated as a dimension, it loses its special status. Past events are not gone. Future events are not waiting to appear. They are positioned differently, just as distant locations in space are positioned elsewhere. You cannot reach them freely, but their existence does not depend on your access to them. The reason this feels wrong is because your experience of movement through space is voluntary, while your experience of time is not. You decide where to walk. You do not decide when you are. But physics does not encode freedom or control into its dimensions. It encodes structure. In space-time, events are defined by 4 coordinates, not 3. 3 describe where an event occurs. 1 describes when. Together, they define a point in the universe. Remove any one of these coordinates, and the event becomes undefined. Time is not an add-on. It is part of the location. This is not a philosophical preference. It is forced by observation. Experiments show that space and time are intertwined. Changes in motion through space affect the passage of time. Differences in gravitational strength alter how clocks tick. These are not illusions or measurement errors. They are consistent, repeatable features of reality. Space affects time because, at a deep level, they are aspects of the same thing. Once space and time merge into spacetime, the idea of a universal present becomes unstable. Different observers carve spacetime into past, present, and future differently depending on how they move. There is no single way to slice reality into moments that everyone agrees on. If time were fundamentally different from space, this disagreement would be impossible. Instead, physics treats all slices as equally valid. Each observer has their own division of spacetime into what they call now, but none of these divisions is privileged. The universe does not select one and discard the rest. This leads to a conclusion that feels deeply unsettling from within human experience. If time is a dimension like space, then moments do not come into existence any more than distant places do. They are already part of the structure. You are not watching reality being written. You are navigating a fixed terrain from a very limited viewpoint. You still experience sequence. You still remember earlier moments and anticipate later ones. But this sequence may reflect the order in which information reaches you, not the order in which reality itself exists. Physics does not deny your experience. It simply does not elevate it to a universal principle. And once time is stripped of its special status, a quiet implication remains. If past and future are embedded in reality the way distant locations are, then the difference you feel between them may say more about the constraints of your perception than about the nature of the universe itself. If time is a dimension, then the universe does not evolve moment by moment. Instead, it exists as a complete structure, sometimes called a block universe. In this model, every event that has happened or will happen already occupies a fixed location in space-time. Your life is not unfolding. It is laid out. This idea does not begin as philosophy. It emerges as a consequence of treating time the same way physics treats space. If locations in space exist, regardless of whether you are standing in them, then moments in time can exist regardless of whether you are experiencing them. The universe, under this description, is not a story being written. It is an object. You are used to thinking of reality as something that updates. Yesterday is gone. Tomorrow is not here yet. But the block universe removes this distinction entirely. Yesterday still exists as part of space-time. Tomorrow exists as well. The only thing that changes is which part of the structure you are currently aware of. From the outside, there is no motion. Every event, from the formation of galaxies to your next breath, occupies a position in the four-dimensional geometry of space-time. These events are not waiting in line. They are not queued to appear. They are already where they are. The universe does not need to move through time any more than it needs to move through space. This is difficult to accept because it contradicts your deepest intuitions about causation. You feel as though the present generates the future. That actions now bring about consequences later. But in the block universe, causation is not a process that creates events. It is a pattern that connects events that already exist. A cause does not produce an effect in time. It is simply related to it within the structure. This does not mean that physics denies cause and effect. It means that cause and effect do not require time to flow. They exist as relationships embedded in space-time. From within the block, You experience those relationships as sequences. From outside it, there is only structure. You might imagine this like a complete map of a city. Every street, building, and intersection exists simultaneously on the map. When you walk through the city, you experience it step by step. But your movement does not bring the streets into existence. It only determines which part of the map you encounter. Your life may be similar. The feeling of progression, of becoming older, of moving toward outcomes, could be the result of your conscious perspective tracing a path through a fixed space-time. The path feels real because it is real to you, but it does not imply that the rest of the structure is incomplete. This is why the block universe feels so disturbing. It challenges the belief that the future is open in a literal sense. It suggests that uncertainty does not come from reality being unfinished, but from your limited position within it. You do not know what happens next, not because it does not exist, but because you have not reached that part of the structure yet. Importantly, physics does not claim that the block universe is visible or accessible in full. There is no perspective from which you could see all of time at once. The theory does not grant omniscience. It only denies the necessity of becoming. Nothing in the block universe implies that you experience your entire life simultaneously. Experience remains local. You occupy one region of space-time at a time. You carry records of earlier regions in the form of memory. You anticipate later regions without being able to observe them. But anticipation does not imply creation. The unsettling implication is not that your choices are irrelevant, it is that they are already part of the structure. The decision you will make tomorrow is as much a feature of space-time as the decision you made yesterday. From within the block, you feel suspense. From within the block, outcomes feel undecided. But the block itself does not share that uncertainty. And once you accept this possibility, a new question emerges quietly but persistently. If the universe is already complete, then what exactly is it that feels like it is still becoming? You assume that everyone shares the same present moment. Einstein's theory of relativity quietly removes this possibility. Observers moving at different speeds disagree on which events are happening now. If the present were objectively real, physics would need to choose one observer as correct. It does not. Before relativity, the idea of a universal present felt obvious. You imagine the universe as synchronized, like a single clock ticking everywhere at once. No matter where you are or how you move, you assume there is a shared now that slices reality cleanly into past and future. Relativity dismantles this assumption without drama. According to the theory developed by Albert Einstein, time is not absolute. The rate at which it passes depends on motion. Two observers moving relative to one another will measure time differently. Their clocks will not agree. And more disturbingly, they will not agree on which events are simultaneous. This disagreement is not a matter of perception or delayed signals. It is built into the structure of space-time itself. Imagine two events occurring at different locations. To you, they happen at the same time. To another observer moving at a different speed, one happens before the other. Both descriptions are equally valid. There is no experiment that can determine which observer is truly correct, because the laws of physics give them equal status. This has a consequence that is easy to overlook. If different observers have different sets of events they call present, then there is no single, observer-independent present moment. The universe cannot be cleanly divided into what exists now and what does not. Any such division depends on how you move through space. If the present were a fundamental feature of reality, this would be impossible. Physics would need a preferred frame of reference, a cosmic standard of rest, a way to declare one version of now as real and discard the others. Relativity does none of this. Instead, it treats all observers symmetrically. Your present is real to you. Another observer's present is real to them. The theory refuses to privilege either perspective, and in doing so, it quietly removes the idea of a universal now from the foundations of reality. This is not an abstract technicality. It forces a radical conclusion. If there is no single present, then reality cannot be something that exists only at one moment in time. Events that are future to you may already be present to someone else. Events you consider already past may still be part of another observer's now. The universe does not wait for you to catch up. From this perspective, the block universe is no longer a strange philosophical add-on. It becomes the simplest way to make sense of relativity. If all events exist within spacetime, then different observers are simply slicing that spacetime in different ways, each calling their slice the present. None of these slices is more real than the others. This reframes your experience of time in a subtle but unsettling way. The sense that the present is special may come entirely from your position and motion, not from the universe itself. What feels like the cutting edge of reality may be nothing more than a viewpoint-dependent boundary. Relativity does not say that your experience is wrong. It says it is local. You still live within your own present. You still make decisions. You still feel moments passing. But physics no longer supports the idea that these moments define what exists and what does not. The universe does not pause to update itself in sync with your awareness. And once the idea of a shared present disappears, another assumption quietly collapses with it. If there is no universal now, then there is no moment at which the future suddenly becomes real. Events that appear simultaneous to you are not simultaneous to someone else moving differently through space. This is not a limitation of perception. It is a measurable feature of reality. The idea of a single universal now collapses under experimental verification. You instinctively believe that simultaneity is simple. Two events happen at the same time, or they do not. This feels objective, obvious, and independent of who is watching. If two clocks strike noon together, you assume that fact is woven into the universe itself. Physics does not agree. In everyday life, the difference never reveals itself because the effects are small. Your speed is low. Distances are short. Light reaches you quickly enough that disagreements about timing remain hidden. But when motion increases or distances stretch, simultaneity begins to fracture. Imagine two lightning strikes hitting opposite ends of a long platform. Standing still relative to the platform, you see both flashes at the same moment. You conclude they were simultaneous. Now imagine someone moving rapidly along the platform. Light from one strike reaches them before the other. They conclude, with equal legitimacy, that one strike happened first. This is not because one of you made a mistake. Both observations are correct within the rules of physics. The reason lies in how reality handles time and space together. Light does not travel infinitely fast. There is no universal signal that announces when something happens. Each observer reconstructs time based on how information reaches them and how they move relative to the events. Crucially, there is no deeper layer beneath this where a true simultaneity waits to be discovered. You might expect physics to say that one observer's timing is distorted, while another's reflects what really happened. But experiments show no such hierarchy. The laws of physics remain consistent for both observers. Neither description can be dismissed. Simultaneity, then, is not absolute. This realization carries a quiet but devastating implication. If there is no objective fact about which distant events happen at the same time, then the present cannot be a universal slice of reality. There is no global now that sweeps across the universe, turning future into present and present into past. Each observer carries their own version of now, shaped by motion and position. This is not philosophical interpretation. It has been tested repeatedly. High-precision clocks placed on fast-moving aircraft drift out of sync with clocks on the ground. Satellites experience time differently than receivers on Earth. These discrepancies are measured, corrected for, and relied upon daily. If simultaneity were absolute, these corrections would be unnecessary. Instead, reality forces engineers and physicists to account for the fact that time itself does not agree across perspectives. What you call now is not something the universe enforces. It is something your frame of reference constructs. This is where the sense of a flowing present begins to lose its footing. You may still feel as though reality is unfolding together everywhere. But physics reveals a universe where different regions are not synchronized in any absolute way. Events do not wait for a cosmic cue to become real simultaneously. The collapse of simultaneity also undermines a deeper assumption. You tend to believe that the future is uniformly unreal and the past uniformly fixed. But if observers disagree on which events are present, they also disagree on which events are future and which are past. An event that lies in your future may lie in another observer's present. An event you consider already settled may not be so from another perspective. This does not mean the future is changeable in a paradoxical way. It means your categories of past, present, and future are not features of the universe. They are features of your situation within it. Once simultaneity disappears, the idea of time as a shared sequence dissolves with it. There is no single timeline everyone inhabits together. There is only spacetime, containing all events and observers tracing different paths through it. And once you accept that, a subtle shift occurs. The present no longer feels like a universal stage on which reality performs. It begins to feel like a personal boundary, drawn by motion, information, and perspective. What you call now is no longer where reality happens. It is simply where you are. If no objective present exists, then there is no physical reason to treat the future as unreal. The past is not gone in physics. It still exists as part of space-time. By the same logic, the future must exist as well, even if you cannot access it. You are used to thinking of the past as something that no longer exists except in memory. Events happened, then vanished, leaving behind traces in records, fossils, photographs, and neural patterns. The future, by contrast, feels empty, undefined, not yet written. This division feels so natural that it rarely feels like a belief. It feels like common sense. Physics does not support this distinction. In space-time, the past does not disappear. Events that occurred yesterday are still located where they occurred in the space-time structure. They are not erased when you move forward along your world line. They remain just as fixed and real as distant places you are no longer standing in. You cannot visit them again, but inability to access something does not make it unreal. A city you left years ago still exists even if you never return. A room behind you still exists even when you stop looking at it. Physics treats past events the same way. They are not present to you, but they are still part of reality's structure. Once this is accepted, a problem appears. If the past is real, despite being inaccessible, then accessibility cannot be the criterion for existence. And if accessibility is not the criterion, then there is no physical justification for declaring the future unreal simply because you cannot reach it yet. The asymmetry you feel between past and future may not be an asymmetry in reality. It may be an asymmetry in how information is distributed. You have records of the past. You carry memories, documents, scars, and causal traces that point backward. You do not have records of the future. This creates a powerful psychological impression that one exists and the other does not. But physics does not define existence in terms of record keeping. Spacetime contains events whether or not they leave traces you can currently access. From the perspective of the block universe, the future is not empty. It is simply unvisited. Just as the past is not gone, the future is not waiting to be created. Both are already part of the structure. You occupy one location within it, moving along a particular path. This does not mean the future is knowable. Existence and knowledge are not the same thing. Physics can allow the future to exist without allowing you to predict it. Determinism is not required for the block universe to hold. Uncertainty can exist within a fixed structure, just as ignorance can exist within a completed map. You may object that this undermines choice, that if the future already exists, then decisions lose their meaning. But physics does not treat decisions as external interventions. They are events too. They belong to the same structure as everything else. Your future choice is not unreal until you make it. It is simply not accessible to you until you reach it. The discomfort here comes from confusing becoming with existence. You are accustomed to thinking that things become real when they happen. Physics suggests that things happen because they are real, not the other way around. From within your experience, the future feels open. From within physics, openness refers to uncertainty, not non-existence. Nothing in the equations marks a boundary where reality suddenly switches on. This reframing forces a difficult realization. The feeling that the future is not yet real is not a statement about the universe. It is a statement about your position within it. You stand between records and expectations. Behind you, information accumulates. Ahead of you, it does not. That imbalance creates the sensation of flow, of anticipation, of possibility. But sensation is not structure. If the past is allowed to exist without your presence, then the future must be granted the same status. To deny it would require a physical mechanism that singles out one region of space-time as real and the rest as merely potential. No such mechanism exists. And once that is accepted, the future stops looking like a blank page. It begins to look like territory you have not yet entered, already part of the world you inhabit. You believe causes come before effects. Physics does not always require this ordering. The equations remain valid even when time symmetry is reversed. What you call causation may be a pattern observed from within a static structure, not a fundamental rule driving events forward. Causality feels non-negotiable. You act and something happens. You touch fire and pain follows. You release an object and it falls. The direction feels absolute. Cause first, effect second. It feels as though time itself enforces this sequence. Physics does not. At the most fundamental level, many of the laws that describe reality do not distinguish between past and future. If you reverse the direction of time in their equations, they still work. The math does not break. The predictions remain valid. Nothing in the formal structure insists that one direction is the correct one. This does not mean physics denies cause and effect. It means causation may not be fundamental. Instead of events producing one another through time, physics often describes relationships between events across space-time. These relationships are symmetric. They connect points without assigning them a preferred temporal direction. From within those relationships, you infer causes and effects because of how you experience information. Your experience enforces directionality. Reality does not. You observe patterns where one type of event reliably appears before another along your path through space-time. You label the earlier one the cause and the later one the effect. This labeling is useful. It allows prediction, control, and survival, but usefulness does not guarantee fundamentality. In a block universe, all events already exist. The explosion and the shattered glass are both part of the structure. The presence of one does not generate the other in time. They are connected by physical laws that describe how such configurations coexist within spacetime. From outside the structure, there is no temporal production. There is only consistency. This becomes especially clear in cases where causality behaves strangely. In certain quantum experiments, correlations appear between events without a clear cause and effect ordering. In others, future measurement choices affect how past events must be described. These results do not violate physics, because physics does not demand a forward-moving causal chain. What feels like retrocausality is often just causality seen without the assumption of flow. You are accustomed to thinking of the present as a point where causes act and the future as a place where effects appear. Remove the moving present, and this picture collapses. Causation no longer needs time to carry it forward. It becomes a static relationship embedded in the geometry of spacetime. This does not mean everything happens for no reason. It means reasons do not push events forward through time. They link events across time. Your sense of agency survives this reframing, but it changes character. When you decide to act, it feels as though your decision brings something into existence. In the block universe, your decision is already there, along with its consequences. The relationship between them is real, but it is not a temporal engine. The discomfort here is subtle. It is not that causation disappears. It is that it stops being the thing you thought it was. You may notice that when you imagine a static universe, causation feels unnecessary. Why would one event cause another if both already exist? But this question assumes causation's role is to create. In physics, causation's role is to constrain. The laws of nature do not tell events how to come into being. They tell events how they can be arranged. From within your experience, the arrangement looks like a sequence. From within physics, it looks like a structure. This reframing also explains why causality feels so tightly bound to time in human intuition. You experience events one after another. You remember earlier states and anticipate later ones. Causality maps naturally onto that sequence. But sequence is a feature of perspective, not of spacetime itself. Once you let go of temporal flow, causation stops being a driver and becomes a description. It does not push reality forward. It describes which configurations are allowed to coexist, and if causation does not require time to move, then one of the last reasons for believing in a flowing universe quietly disappears. What remains is a reality where events are connected, constrained, and ordered without ever needing to arrive. Everything you experience feels dynamic, yet at the deepest level, reality may be frozen. Motion, growth, decay, and aging could all be relationships between fixed points in spacetime, not processes that generate new moments. You wake up older than you were yesterday. Your body changes. Objects move. Stars burn out. Entire civilizations rise and fall. Change feels like the most obvious fact about existence. It feels impossible that beneath all this motion, nothing is actually moving. But physics does not describe change the way you experience it. In the deepest descriptions of reality, there is no mechanism that creates new moments. There is no process that adds fresh slices of time to the universe. Instead, there is a complete space-time structure in which different states coexist. What you call change is a comparison between those states, not the emergence of something new. Consider motion. When you see an object travel from one place to another, you imagine it occupying a series of positions over time. But physics can describe that motion as a continuous path already laid out in space-time. The object does not move through time in the way you imagine. It exists as a four-dimensional shape extended across time as well as space. What you perceive as movement is your traversal along that shape. The same applies to growth and decay. A tree does not grow by adding moments to reality. Its entire lifespan exists as a structured sequence of states within space-time. The seed, the sapling, the mature tree, and the rotting remains are all part of the same object extended across time. Aging works the same way. You do not become older because time advances. You are older at some locations in space-time and younger at others. From within your perspective, this feels like a process. From within physics, it is a relationship between different temporal coordinates of the same entity. This is where the stillness becomes unsettling. If all states already exist, then nothing is truly coming into being or passing away. Birth and death are not moments where existence switches on or off. They are boundaries within space-time, places where certain structures begin or end. The universe itself does not react to them. This does not diminish their meaning to you. It reframes their status in reality. The feeling of change may arise not because reality is dynamic, but because your awareness is localized. You experience one region of space-time at a time. You carry information from earlier regions in the form of memory. You do not have access to later regions yet. This creates the sensation of flow. But flow is not required by the structure itself. This idea feels disturbing because it removes the idea of creation from time. You are used to thinking that moments are produced, that the present generates the future. A frozen universe suggests that the future is not produced at all. It simply is. What changes then is not reality, but your position within it. You might resist this by pointing to processes that feel undeniably active: chemical reactions, neural activity, the firing of neurons as you think these thoughts. But physics describes these processes as patterns within space-time, not as engines that push reality forward. Even change can be static when viewed as a whole. This does not mean nothing happens. It means happening does not require time to flow. It requires only that different states exist in a structured relationship. The stillness beneath change is not emptiness. It is full, dense, complete. And once you begin to see reality this way, another subtle shift occurs. The universe no longer feels like a stage where events unfold. It begins to feel like an object you are embedded within, experiencing only one cross-section at a time. The unsettling part is not that reality is frozen. The unsettling part is that it never needed to move at all. If all moments exist, why do you experience only one at a time? One explanation treats consciousness as a localized perspective moving through a static structure, like a spotlight illuminating different frames of a film that already exists in full. You never experience your entire life at once. You experience this moment, then another, then another. No matter how convincing the block universe appears in physics, your awareness seems to contradict it. Something feels like it is moving. Something feels like it is advancing. That something is not the universe. It may be consciousness itself. From your perspective, awareness feels continuous, as though it slides smoothly from one moment to the next. But this sensation does not require time to flow. It only requires that consciousness be restricted to accessing one region of space-time at a time. Imagine a completed film reel. Every frame exists simultaneously on the strip. Nothing about the reel itself moves. Yet when light passes through it and the frames are projected in sequence, motion appears. The motion is not in the film. It is in the process of illumination. Your consciousness may function in a similar way. Physics does not describe consciousness as something that exists everywhere in space-time at once. It appears to be tied to physical systems, localized in space and extended in time. Your brain occupies a particular world line. Along that world line, there are different physical states corresponding to different moments. Each of those states may be associated with its own instance of conscious experience. From this view, there is no single consciousness that travels through time. There is a series of conscious states, each located at a different point in space-time. Each state experiences itself as present. Each has access to memories encoded in earlier states. None has access to later ones. The feeling of movement arises because each conscious state contains records of previous states, but not of future ones. This asymmetry creates the illusion of flow. You remember yesterday. You do not remember tomorrow. From within any given conscious moment, the past feels fixed and the future feels open. But this openness may not reflect the structure of reality. It may reflect the structure of memory. Memory does not reach forward. Your brain stores information about earlier states. It carries traces of what came before. Those traces shape perception, expectation, and identity. They give you a sense of continuity, but they do not imply that consciousness itself is moving through time. They only imply that each conscious state is linked to others in one direction. From outside the block universe, there is no spotlight moving. There are only illuminated regions, each lit from within by its own awareness. The spotlight metaphor is useful, but it can be misleading. It suggests a single entity sweeping across time. A more precise picture is stranger. Each moment of consciousness is self-contained. It experiences itself as now because there is no alternative reference available to it. You never experience being in the past or future because there is no experience that is not present to itself. This reframing dissolves a common objection to the block universe. It does not require a mysterious observer drifting through time. It requires only that consciousness be local, sequentially connected, and asymmetrically informed. The cost of this explanation is subtle but heavy. It suggests that the sense of becoming, of moving forward, of leaving moments behind, may not correspond to anything moving at all. It may be a narrative generated by how conscious states are arranged and connected. You feel like a single self traveling through time. Physics allows for the possibility that this self is a chain of related experiences, each existing at a different location in space-time, each convinced it is the only one that exists. Nothing about this picture denies the reality of experience. It denies only the assumption that experience tracks a moving present. And once consciousness is removed from the role of temporal engine, another assumption quietly weakens. The feeling that time passes may tell you more about how you remember than about how reality exists. You remember the past, but not the future. This asymmetry feels fundamental. Physics suggests it may not be. Memory could simply be a structural feature of certain moments, not evidence that time itself flows in one direction. You take this imbalance for granted. You carry images, sensations, and records of what has already happened. You do not carry memories of what has not. This feels like proof that the past exists while the future does not. It feels like time must move forward because memory points backward, but physics does not require this interpretation. Memory is not a passive mirror of time. It is a physical process. It depends on changes in matter, energy, and information storage. Neurons alter their connections. Molecules settle into stable configurations. Traces are left behind. None of this requires time to flow. It requires only that certain states of the universe contain records of other states. A footprint in sand does not prove that time moves forward. It proves that one configuration of sand encodes information about another. Memory works the same way. In spacetime, a moment that contains records of earlier moments will experience those earlier moments as past. A moment that does not contain records of later moments will experience those later moments as future. The directionality comes from information, not from time itself. You never remember the future because future records are not available to you. Not because the future does not exist, but because the structure of physical law does not allow information to flow that way. This distinction matters. It shifts the explanation for temporal direction away from time and toward entropy, stability, and information storage. Certain physical processes naturally leave traces, others do not. This creates an arrow in experience without requiring an arrow in time. From within a block universe, memory becomes a local feature. Some regions of spacetime contain records of other regions. Those regions experience an apparent past. Other regions contain expectations, models, and predictions, but not records. Those regions experience an apparent future. The asymmetry feels deep because it is embedded in your biology. Your brain evolved to preserve information that increases survival. It stores data about what has already happened because that data is reliable. It does not store data about what has not happened because such data cannot be confirmed. This evolutionary constraint produces a psychological arrow of time that feels absolute. But evolutionary usefulness does not imply metaphysical truth. From the perspective of physics, a memory is just a correlation between two states of matter at different spacetime locations. One state contains information about the other. That is all. There is no requirement that one state came into existence before the other in any fundamental sense. This reframing has an unsettling consequence. If memory defines your sense of pastness, then the past is not a region of spacetime that has vanished. It is a region that left records. The future may exist just as fully, but without leaving records in your current location. You stand at a point in spacetime where information converges from one direction but not the other. That convergence creates the illusion of flow. The illusion is convincing because it is consistent. Every moment you experience is structured this way. Each contains traces of earlier moments and none of later ones. Each therefore feels like a moving present, carrying a growing archive behind it. But from outside this perspective, there is no archive growing. There is only a fixed distribution of records across spacetime. This also explains why memory feels reliable and anticipation feels uncertain. Memory is anchored to existing records. Anticipation is anchored to models, guesses, and probabilities. Both are features of the present moment, not indicators of what exists or does not exist. Physics does not say you cannot know the future because it is unreal. It says you cannot know it because information about it is not available to you yet. Once this is understood, memory stops looking like evidence for temporal flow. It starts looking like a constraint on perspective. You remember the past not because time moved forward, but because you are located at a point in space-time where information happens to point one way. And if memory points backward by structure rather than by necessity, then the direction you experience may not belong to time at all. It may belong only to you. The arrow of time is often linked to entropy, the tendency toward disorder. But entropy describes relationships between states, not the creation of time itself. A complete space-time can contain increasing entropy without requiring time to move. You are often told that time flows forward because entropy increases. Ice melts, smoke disperses, systems move from order to disorder. This progression feels irreversible, and it seems to give time a direction. Past states look ordered, future states look chaotic. It feels as though entropy is pushing the universe forward, but entropy does not push anything. Entropy is a measure. It compares how many microscopic configurations correspond to a given macroscopic state. High entropy states are more statistically common than low entropy ones. That is all. Entropy does not generate motion, and it does not create time. It describes how different states relate to one another within space-time. This distinction is easy to miss because entropy aligns so neatly with your experience. You remember the ordered state. You observe the disordered one. The sequence feels inevitable. But inevitability does not imply flow. It implies structure. In a block universe, every state of a system already exists at its own location in space-time. Some of those states have low entropy. Others have high entropy. When you trace a path through these states, entropy appears to increase along that path. But the increase is not happening. It is simply there. Entropy does not require time to move any more than altitude requires space to move. A mountain does not rise as you climb it. The elevation difference already exists. Your movement through space creates the experience of ascent. Likewise, entropy differences already exist across space-time. Your perspective creates the experience of direction. This becomes clearer when you consider that the laws governing entropy are time-symmetric at the fundamental level. The equations that describe microscopic interactions work equally well forward and backward in time. They do not forbid entropy from decreasing. They only make it statistically unlikely from your position within space-time. The arrow of time, then, is not written into the laws themselves. It emerges from boundary conditions. Specifically, it emerges from the fact that the universe appears to have begun in an extremely low entropy state. From that condition, most paths through space-time lead toward higher entropy. Observers embedded in such paths experience a consistent directionality, but directionality does not equal motion. The universe does not start at low entropy and then generate higher entropy by moving forward in time. All entropy states exist. The low entropy boundary simply anchors one end of the structure. From that anchor, entropy gradients are defined. You experience yourself moving along one such gradient. This reframing removes entropy as an engine of time. It becomes a marker, not a motor. It tells you how states differ, not how they come into being. The illusion of direction arises Because your consciousness is embedded in a region of spacetime where entropy increases along your world line. You remember lower entropy states because records form more easily there. You do not remember higher entropy states because records degrade. Memory, causation, and anticipation all align with this gradient. They reinforce one another. Together, they create a powerful impression of temporal flow. But none of them require time to move. A complete spacetime can contain entropy gradients just as a complete landscape can contain slopes. The existence of a slope does not imply the landscape is shifting. It only implies differences across positions. This is why entropy cannot rescue the idea of a flowing present. It explains why you experience a direction. It does not explain why moments should come into existence one by one. Once entropy is understood as relational rather than generative, its role becomes quieter and more unsettling. It stops explaining why time happens and starts explaining why experience is asymmetric. The arrow of time may be nothing more than the arrow of perspective. And if direction comes from where you are, rather than from what time does, then the deepest sense of motion you feel may not belong to the universe at all. It may belong to the way you are situated within it. None of the core equations of physics include a preferred present moment. They describe entire histories at once. The absence of now is not a bug. It is a feature that has survived every experimental test. You expect the present to matter. It feels central. Everything you do happens now. Every decision, every sensation, every thought seems anchored to this moment, as if reality itself is oriented around it. If physics were a description of how the world truly works, you would expect it to acknowledge this centrality. It does not. When physicists write down the equations that govern motion, energy, fields, and matter, they do not single out the present. The equations do not say what is happening now and then update themselves. They describe relationships that hold across all time at once. In many cases, the equations do not even distinguish past from future. A physical law typically takes the form of a rule that connects states at different times. It does not privilege one of those times as more real. You can often specify conditions at one moment, solve the equations, and obtain the entire history of the system. Forward and backward. The mathematics does not pause at the present. It does not recognize it. This is not an oversight. Physicists have looked for a way to insert a moving present into the laws of nature. They have searched for a variable that marks the current moment, a mechanism that advances time step by step, a physical process that turns future into present. None has been found. And more importantly, none is needed. Every successful prediction made by physics works without a preferred now. From planetary motion to atomic transitions, from gravitational waves to particle collisions, the equations perform flawlessly while remaining indifferent to the present moment you experience so vividly. If the present were a fundamental feature of reality, its absence from the laws would be inexplicable. Instead, the consistency of physics suggests that the present is not part of the universe's basic structure. It is part of how you interact with that structure. The equations describe entire trajectories, not moments. They describe world lines, fields extended across space-time, and constraints that apply globally. In this sense, physics does not model the universe as something that unfolds. It models it as something that exists. This becomes especially clear in formulations where the laws are expressed as boundary conditions rather than evolution rules. In these approaches, you specify conditions across a region of spacetime, and the laws determine which configurations are allowed. Nothing needs to happen. Nothing needs to advance. Reality is selected, not generated. From this perspective, the present moment you experience is not something the universe produces, it is something you occupy. Physics does not deny that you experience now. It simply does not elevate that experience to a governing principle. This mismatch can feel unsettling. It creates the impression that physics is incomplete, that it is missing something obvious. But the history of science suggests the opposite. When a feature is absent from every successful theory, it is usually because that feature belongs to perspective, not to structure. Color feels fundamental, yet it is not present in physics. Sound feels intrinsic, yet physics describes only vibrations and pressure waves. The present may belong to this category. It feels unavoidable because you cannot step outside it. But inability to escape something does not make it fundamental. The absence of now has been tested implicitly millions of times. Every experiment that confirms a prediction derived from timeless equations reinforces the same conclusion. Reality does not need a moving present to function. You do, and that distinction matters. If the laws of physics do not care about now, then now may not be where reality happens. It may be where experience happens. The universe does not mark the present. It does not update itself. It does not wait. The present is not written into the world. It is written into you. At the quantum level, time behaves even less intuitively. Certain interpretations treat events as existing without a clear temporal order until measured. This does not restore a flowing present. It weakens it further. You might expect quantum mechanics to bring time back into focus, to restore sequence, to reestablish a clear before and after beneath the strangeness. Instead, it removes even more of the structure you rely on. In classical physics, events happen at definite times. Even if time does not flow, there is still a clear ordering. Quantum mechanics disrupts even that. At the quantum scale, particles do not always have well-defined properties before interaction. Position, momentum, energy, and sometimes even order itself remain undefined until a measurement occurs. The theory does not describe particles as moving smoothly through time from one state to another. It describes probability distributions over possible outcomes. And in some interpretations, those probabilities are not arranged in a clear temporal sequence. There are quantum experiments where it is impossible to say which event happened first without contradicting the theory's predictions. Attempts to impose a definite order break the mathematics. The equations remain consistent only when the ordering is left ambiguous. This ambiguity is not due to lack of knowledge. It is not something that could be resolved with better instruments. It is built into the formalism. You may want to imagine that beneath the uncertainty, events still occur in some hidden sequence, but quantum mechanics does not require this. In fact, many of its most successful interpretations function without assuming a definite underlying timeline. This creates a problem for the idea of a flowing present. If events do not have a fixed order until measurement, then there is no clear sense in which one moment replaces another at the fundamental level. The present cannot be the engine that selects reality from possibility, because reality itself does not settle into order until interaction occurs. And even then, the interaction does not privilege a universal now. Some interpretations treat the quantum state as a description of the entire system across time, not as something that evolves through a sequence of present moments. Measurement does not happen at a moving now. It happens at a specific location in spacetime, correlated with other events. Quantum mechanics does not say the present chooses outcomes. It says correlations exist between events. This becomes especially unsettling in experiments involving delayed choice. In these setups, decisions made later affect how earlier events must be described, not by changing the past, but by revealing that the past was never well defined to begin with. The order you assumed was there turns out to be a projection. If the past itself can lack definite properties until later interactions, then the idea of a fixed, flowing timeline becomes even harder to sustain. The present cannot be the point where reality solidifies if reality does not require solidification at that point. Instead, quantum mechanics suggests a reality that is relational rather than sequential. Events are defined through their connections, not through their position in a universal temporal order. What exists is not a chain of moments, but a network of correlations embedded in spacetime. From within that network, you experience sequence because your observations occur along a particular path, but the network itself does not privilege that path. This does not mean time is meaningless in quantum mechanics. Time still appears in the equations as a parameter, but it does not behave like a flowing substance. It does not enforce a universal now. It does not dictate a single direction of becoming. Quantum theory works precisely because it avoids committing to such assumptions. The more deeply physics probes reality, the less it resembles a story unfolding in time. It begins to resemble a fixed structure where order, causation, and sequence emerge only in certain contexts, from certain perspectives. Quantum mechanics does not rescue the present. It dissolves it further. And if even at the most fundamental level events do not require a definite temporal order, then the sense that reality is continuously arriving at now becomes harder to defend. The present begins to look less like a feature of the universe and more like a condition of observation, a boundary drawn by measurement, not by time itself. Experiments show that choices made in the present can determine how particles behaved in the past. These results do not imply time travel, but they challenge the idea that the past was ever fixed in the way you imagine. You assume the past is settled. Whatever happened has already happened, locked into place, immune to anything you might do now. Decisions affect the future, not the past. This assumption feels so basic that questioning it sounds absurd. Quantum experiments quietly undermine it. In delayed choice experiments, a particle is sent toward an experimental setup where it can behave in one of two incompatible ways. Which behavior it exhibits appears to depend on how the experiment is arranged. The unsettling part is that the choice of arrangement is made after the particle has already entered the system. From your perspective, the decision comes too late to matter. And yet, the outcome depends on it. When the results are analyzed, the particle's earlier behavior aligns with the later choice, as if it somehow anticipated the future configuration. Not predicted it, not reacted to it, simply behaved in a way that is only consistent once the later choice is taken into account. This does not mean information traveled backward in time. No signal is sent into the past. No paradox is created. Causality is not violated in any practical sense. What is violated is your assumption that the particle had a definite past before the choice was made. Quantum mechanics does not describe the particle as having chosen a specific history that you later discover. It describes the particle as existing in a state where multiple histories remain possible until the experimental context is finalized. The past, in this sense, is not something waiting to be revealed. It is something that becomes defined only in relation to later events. The key word here is relation. The particle's behavior is not determined by a sequence of moments flowing from past to future. It is determined by a set of constraints that span across time. The experiment must be consistent as a whole. the earlier and later events must fit together within the structure of the theory. From within that structure, it makes no sense to ask what the particle really did before the choice. There is no fact of the matter independent of the full experimental context. This is deeply uncomfortable because it reverses the order you rely on to make sense of the world. You think the past explains the present. These experiments suggest the present helps define the past, not by changing it, but by completing it. If the past were a fixed sequence of events unfolding moment by moment, this would be impossible. The results would contradict themselves. The experiments work precisely because the past is not treated as something that independently exists in a finished state. Instead, the past is a region of spacetime whose properties are constrained by the entire experimental arrangement, including decisions made later. This fits naturally with the block universe view. In a static spacetime, there is no privileged direction of explanation. Events are related across time without one needing to generate the other. Consistency replaces causation as the guiding principle. From within your experience, this looks like retroactive influence. From within physics, it looks like a single structure being described all at once. The discomfort you feel arises because you are still imagining time as something that flows. You imagine the particle traveling forward, making choices, accumulating properties. The experiment refuses to cooperate with that picture. It forces you to consider a different possibility. That the particle's history is not written until the entire structure it belongs to is specified. Your choice does not reach back and alter the past. It selects which consistent history applies within a spacetime that already contains both. This does not restore certainty. It removes it from where you thought it lived. The past begins to look less like a frozen archive and more like a region whose meaning depends on context. Not subjective context, but physical context that spans time. Once this is accepted, the sense of a rigid, untouchable past starts to soften, not into something changeable, but into something relational. And if the past itself is not fully defined until later events are taken into account, then the idea of time as a one-way process from fixed past to open future quietly breaks down. The past was never as settled as you thought. It only felt that way because you were standing on one side of it. If the future already exists, your choices seem meaningless. Yet the block universe does not eliminate decisions. It reframes them. Your choices are part of the structure, not external forces acting upon it. The moment you hear that the future may already exist, a familiar fear appears. If tomorrow is already written into space-time, then what room is left for choice? What difference does it make what you decide if the outcome is already there? This reaction is understandable. It comes from imagining the future as something finished that you are being dragged toward against your will. But that is not what the block universe implies. The block universe does not say events happen without reasons. It says events exist in relation to one another. Your decisions are not overwritten by the structure. They are embedded within it. You are not a passive observer watching a predetermined script unfold. You are a physical system whose deliberations, doubts, impulses, and actions occupy specific locations in space-time. Those mental processes are just as real as anything else described by physics. Your choice is not missing from the future. It is part of it. The confusion arises because you tend to imagine free will as something that must float above reality, intervening at the present moment to push the universe in one direction rather than another. If the universe is already complete, this picture seems impossible. Physics never required such a picture. Free will, as you experience it, does not require the future to be empty. It requires that your decisions arise from who you are, what you know, what you value, and what you perceive. All of that can exist within a block universe without contradiction. When you choose, you are not selecting between unreal futures. You are realizing one of the many consistent patterns that already exist within spacetime. From your perspective, the choice feels open because you do not know which pattern you occupy until you reach it. Uncertainty is not the same as non-existence. You do not feel your choices are meaningless because you lack access to the future. You feel them to be meaningful because they express your internal states. Those internal states are part of the causal structure of the universe, whether time flows or not. The block universe does not remove agency. It removes the idea that agency must create reality moment by moment. This distinction matters. It allows free will to exist without requiring metaphysical exceptions to physics. Your will does not need to override space-time. It only needs to be one of the things space-time contains. From within your experience, the future feels undecided because you do not know what you will choose. That ignorance is genuine. It is not staged. Physics does not grant you foreknowledge simply because the structure exists. Your experience of deliberation is not an illusion. It is a real process unfolding at a particular location in space-time. The fact that the outcome of that process is already part of the structure does not make the process irrelevant. A mountain path can be fully mapped without making the act of walking meaningless. You still take each step. You still decide where to place your foot. The map does not walk for you. The discomfort you feel comes from equating freedom with indeterminacy. You assume that for a choice to be free, the future must be genuinely undefined. Physics suggests a different possibility. A choice can be free because it flows from you, not because the universe waits to see what happens. This reframing is subtle, and it does not offer comfort. It does not tell you that everything could have gone differently in some absolute sense. It tells you that what happens happens through you, not around you. Your decisions matter because they are part of reality's structure. They shape the patterns that exist within space-time. They are not spectators. The block universe does not strip you of authorship. It removes only the illusion that authorship requires an unfinished world. And once that illusion fades, free will does not disappear. It simply stops needing time to move in order to exist. Knowing the future and the future existing are not the same thing. Physics does not say the future is knowable. It says it may be real, regardless of whether it can be predicted or accessed. You often blur these two ideas together without noticing. If something exists, you assume it must be knowable in principle. If it cannot be known, you assume it does not yet exist. This intuition feels reasonable, but physics does not share it. Existence and access are different categories. There are many things that exist which you cannot know. You cannot know the exact position of every particle in your body. You cannot know the precise state of the universe beyond your observable horizon. You cannot know the detailed outcome of a chaotic system far into the future. None of this threatens the reality of those things. The future can belong to the same category. When physics suggests that the future may already exist, it is not claiming that the future is readable, predictable, or available. It is not claiming that the universe is transparent. It is making a quieter claim: that existence does not depend on epistemic access. You do not experience uncertainty because the future is unreal. You experience uncertainty because information is limited. This distinction is easy to miss because prediction plays such a central role in how you interact with the world. You plan, forecast, estimate, and model. When prediction fails, it feels like reality itself is undefined, but unpredictability is not emptiness, it is opacity. Physics is full of systems whose future states exist but cannot be predicted in detail. Chaotic systems amplify tiny differences beyond any measurement. Quantum systems impose fundamental limits on what can be known. Even classical systems quickly become computationally inaccessible. None of this implies that their future states are unreal. In the block universe view, the future exists as part of spacetime, whether or not you can calculate it. Your inability to know it does not place it in a different ontological category from the past. It only places it outside your informational reach. This matters because much of the resistance to an existing future comes from fear of foreknowledge. You imagine that if the future exists, it must be fixed in a way that removes surprise, choice, and uncertainty. But existence does not grant visibility. A sealed room exists even if you cannot see inside it. Your future experiences can exist without being accessible to you now. The fact that you cannot predict them is not evidence that they are not there. It is evidence that the universe does not organize itself around your knowledge. Physics is indifferent to what you can anticipate. This reframing also dissolves a common misunderstanding. People often hear that the future exists and immediately think of destiny or fate, a single inevitable storyline revealed in advance. Physics does not require this picture. It allows for complexity, branching descriptions, and uncertainty within a fixed structure. Existence does not mean inevitability in the sense you fear. It means inclusion. Your future choices are included in spacetime, but they are not included as known outcomes from your current position. They remain uncertain because uncertainty is a relationship between a system and an observer, not a property of reality itself. You do not feel uncertainty because the future is unreal. You feel it because you are located here, not there. From another location in spacetime, what you call the future would feel just as present, just as immediate, just as opaque in its own forward direction. This symmetry is unsettling because it removes your privileged position. You are not standing at the edge of creation. You are standing at one point within a larger structure with limited access in one direction. The universe does not hide the future from you because it is not yet made. It hides it because information has not reached you. Once this distinction becomes clear, the idea of an existing future loses some of its emotional weight. It stops feeling like a threat to meaning and starts feeling like a statement about scale. Reality does not revolve around what you can know. The future can exist without being predictable, accessible, or revealed. And that difference is precisely why its existence does not collapse your experience of uncertainty. It explains it. If all moments exist, why are you confined to one slice? The answer may lie in the architecture of conscious systems, not in time itself. Experience could be constrained by information flow, not by reality's structure. You might accept that the future exists and still feel something is missing. If all moments are real, why do you not experience them together? Why are you trapped in a narrow present, unable to access what already exists ahead of you? The answer may have nothing to do with time. It may have everything to do with how experience works. Conscious systems do not absorb information all at once. They process it locally, incrementally, and under strict physical constraints. Your brain is not a global observer of spacetime. It is a finite system embedded in it, bound by energy limits, signal speeds, and causal structure. You cannot experience the future for the same reason you cannot see behind a wall. Not because what lies beyond does not exist, but because information from there has not reached you. Experience requires information. Information requires physical interaction. And physical interaction is limited by how signals propagate through space-time. Your conscious experience is anchored to your body, and your body follows a specific path through space-time. Along that path, information arrives from nearby regions, from earlier events whose signals have had time to reach you. Information from later regions has not. This is not a rule imposed by time itself. It is a constraint imposed by physics. Light travels at a finite speed. Causal influence propagates locally. Information cannot leap ahead of interaction. These limits ensure that conscious systems experience only a narrow cross-section of reality, even if reality itself is complete. You are not confined to the present because the future is unreal. You are confined because your access to information is local and directional. This reframes the mystery. Instead of asking why time reveals itself gradually, you begin to ask why information does. Your brain constructs experience by integrating signals as they arrive: sensory input, memory recall, internal simulation. All of this depends on physical processes unfolding within the brain, which itself exists at a specific space-time location. At that location, only certain information is available. Future events cannot influence your present experience because their signals have not yet intersected your world line. This does not require the future to be non-existent. It requires only that information travels along constrained paths. Even if the entire universe exists as a block, information still flows locally within it. This also explains why you do not experience your entire past all at once. Past events exist, but you do not re-experience them directly. You experience records, stored traces, reconstructed memories. These are present structures encoding information about other regions of space-time. Your experience is always mediated. You do not access reality directly. You access representations shaped by physical constraints. The narrowness of experience is not a feature of time. It is a feature of embodiment. Once this is understood, the idea of a moving present becomes unnecessary. There is no need for reality to unveil itself moment by moment. Conscious systems simply encounter information as it becomes available to them along their paths. The future is inaccessible for the same reason distant galaxies are inaccessible beyond a certain horizon. Not because they do not exist, but because their information cannot reach you yet. This comparison is unsettling because it treats time like space in the deepest sense. Just as there are regions of space you cannot see, there are regions of time you cannot experience. The barrier is not existence, it is connectivity. From another location in space-time, another conscious system would experience what you call the future as its present, equally confined, equally local, equally unaware of what lies ahead of it. No one experiences all of time at once because no physical system has access to all information at once. This limitation is not a flaw. It is what makes experience possible at all. A consciousness that experienced everything simultaneously would not experience sequence, distinction, or change. It would have no perspective. Your confinement to a slice is not a prison imposed by time. It is the condition that allows you to experience anything at all. And once you see this, the mystery shifts again. The question is no longer why the future is hidden. The question is why you ever assumed it needed to be revealed in the first place. Nothing in physics suggests the universe refreshes frame by frame. There is no cosmic clock ticking forward. There is only a static totality that contains every tick you will ever count. You instinctively imagine reality as something that updates. One moment replaces the next. The universe feels like a screen refreshing constantly, advancing step by step through time. This intuition is reinforced by everything you experience. Clocks tick, hearts beat, seconds pass. But none of this requires the universe itself to update. In physics, there is no master clock, no global pulse, no mechanism that advances the universe from one state to the next. The equations do not contain an instruction that says, now, advance time by 1 unit and recompute reality. Instead, they describe relationships that already span time. When physicists model a system, they do not simulate the universe marching forward moment by moment. They specify conditions and solve equations that describe entire trajectories. The result is not a sequence being generated. It is a structure being revealed. This difference is subtle but critical. A simulation updates because it is incomplete and must be computed step by step. The universe does not need to compute itself. There is no evidence that it runs on discrete frames or refresh cycles. There is no physical process that corresponds to the idea of the present being replaced by the future. The sensation of updating comes from you. Your brain processes information in sequences. Neurons fire, signals propagate, states change. These internal updates create the impression that reality itself is updating. But what is changing is your internal representation, not the universe. This becomes clearer when you consider that different observers do not agree on what should be updating at the same time. If the universe refreshed globally, there would need to be agreement on when each refresh occurs. Relativity shows that such agreement is impossible. There is no shared beat. Instead of a ticking universe, physics offers a static spacetime containing all events. Clocks do not measure time passing in the universe. They trace paths through spacetime and compare intervals between events along those paths. A clock does not reveal a cosmic now. It reveals how much spacetime it has traversed. This reframing removes the idea of universal progression. The universe does not move from state to state. It contains all states. What changes is which states are compared, which are remembered, which are anticipated. The image of a refreshing universe is a psychological artifact. You feel as though now replaces before because memory accumulates. Each moment contains traces of earlier moments, but not later ones. This accumulation creates the impression of layering, of something being added, but nothing is being added to reality. There is no growing block, no expanding present, no frontier where existence suddenly switches on. All of that imagery comes from how conscious systems process information locally. Physics does not require reality to keep up with experience. This also explains why the idea of a universal present has never appeared naturally in fundamental theory. A global update would require a preferred ordering of events, a privileged frame of reference, a universal synchronization. Every attempt to introduce such features conflicts with observation. The universe appears indifferent to the idea of now. What you experience as the passage of time is the sequence of states your brain occupies along its world line. Those states are arranged in a particular order, but they do not generate one another. They coexist within the space-time structure. The ticking you hear is not the universe advancing. It is you moving. This realization feels disorienting because it strips away a familiar mental image. You are used to thinking of time as something that carries you forward. Physics suggests the opposite. You carry yourself through a static landscape of moments. Nothing updates, nothing refreshes, nothing waits. The universe does not arrive. It is already there. And once this is accepted, the question that remains is no longer about when things happen. It is about where you are within what already exists. You feel like you are becoming someone over time. Physics describes you as a series of states extended across space-time. Becoming may be a narrative imposed by your perspective, not a feature of the universe. You think of yourself as a process. A past version of you led to the present one, and the present version is shaping the future. You imagine growth, development, learning, decay. Your identity feels like something that unfolds. Physics does not describe you this way. From the perspective of space-time, you are not a single point moving forward. You are a four-dimensional structure. Every version of you that ever exists occupies a location in space-time, just as different parts of a mountain occupy different locations in space. Childhood, adulthood, old age are not stages that replace one another. They are regions. Nothing in physics says one region becomes another. What you call becoming is the experience of occupying one region while containing information about others. You remember earlier states. You anticipate later ones. This creates the feeling of continuity, of change, of narrative progression. But narrative is not structure. The universe does not tell a story. You do. From the outside, there is no transformation. There is only variation across space-time. The younger you does not vanish when the older you exists. Both are equally real, equally embedded in the structure of reality. They do not compete for existence. This is unsettling because it challenges how you think about identity. You believe you are becoming someone new because you cannot experience all versions of yourself at once. Each moment feels definitive. Each decision feels like it overwrites what came before. Physics suggests nothing is overwritten. Your earlier selves are not erased. They are simply elsewhere in space-time. Your later selves are not being created. They are already there, even if inaccessible to you now. The sense of becoming arises because your experience is confined to a single slice. From that slice, everything feels temporary. You feel as though you are passing through states rather than being extended across them. But this feeling may be misleading. A book character seems to change as you read page by page. From the outside, the character exists fully across all pages at once. The change is real within the story, but the book itself does not transform as you read it. Your life may be similar. This does not trivialize growth or learning. It reframes them. Learning is not the creation of a new self out of nothing. It is the relationship between different states of you across space-time. Growth is not emergence. It is structure. From within experience, becoming feels unavoidable. From within physics, it is optional. You might resist this by pointing to effort, to struggle, to moments where you consciously try to change who you are. These feel active, generative, but effort itself is a physical process. It occupies space-time. It does not require time to flow to be real. The effort you will make tomorrow exists just as fully as the effort you made yesterday. The difference is that you only experience one of them now. This reframing also changes how failure and regret appear. If becoming is not fundamental, then you are not constantly leaving behind obsolete versions of yourself. Those versions still exist. They are not mistakes erased by progress. They are parts of the structure that led to other parts. Nothing needs to be redeemed by the future. Nothing needs to be fixed by becoming. This can feel disturbing because it removes the idea of transformation as a fundamental engine of meaning. But it also removes a quieter burden. The burden of thinking that reality depends on you constantly becoming something else. Physics does not require you to become. It only requires you to be at different locations in space-time. The story of becoming is powerful because it organizes experience. It helps you plan, reflect, and adapt. But stories are not laws. They are tools. The universe does not tell you that you are becoming. It contains multiple versions of you and remains indifferent to how you narrate the relationship between them. Once this is seen, identity begins to feel less like a river and more like a landscape. You do not flow from one self to another. You are extended across them. And the feeling of becoming, so central to how you understand yourself, may be nothing more than what it feels like to be localized within a much larger whole. A static universe removes the comfort of open-endedness. It challenges the belief that reality is still being written. The discomfort you feel is not accidental. It is the collision between intuition and structure. You feel unsettled because something familiar has been taken away. Not a fact, but a feeling. The feeling that the future is open. The sense that reality is still in progress, that something genuinely new is waiting to happen. A static universe does not offer that comfort. If all moments exist, then the universe is not anticipating anything. It is not holding its breath. It is not waiting to see what you will do. That idea feels cold, even hostile, because so much of your emotional life depends on the belief that the future is not yet fixed. Hope relies on openness. Regret relies on irreversibility. Motivation relies on the sense that effort pushes reality forward. When these intuitions collide with a structure where nothing is being written in real time, the result is discomfort. This discomfort is not philosophical confusion. It is psychological friction. Your brain evolved to operate inside a world that feels unfinished. Planning, learning, fear, desire, and adaptation all assume a future that is not yet there. You act as though your decisions carve paths into an empty space ahead of you. This assumption works. It helps you survive. Physics does not care whether it feels good. The block universe threatens intuition, not by contradicting experience, but by explaining it too well. It tells you that the sense of openness is not a feature of reality, but a feature of limited access. You feel the future is unwritten because you cannot see it, not because it does not exist. That reframing is deeply unsettling. It means that anticipation is not evidence of becoming. It is evidence of ignorance. It means suspense does not arise because the universe is undecided, but because you are. This feels like a loss of agency, even when it is not. Part of the discomfort comes from the way you imagine a static universe. You picture it as rigid, mechanical, predetermined. But this image sneaks in assumptions that physics does not require. Static does not mean simple. Complete does not mean controlled. A mountain range is static, but it is not uniform. A map is complete, but it is not empty of detail. A finished structure can still contain complexity, unpredictability, and internal perspective. What is unsettling is not that everything exists. It is that existence does not wait for you. The idea that reality is still being written places you near the center of things. It suggests that the present moment has special authority. That now is where meaning happens. Removing that privilege feels like removal of significance. But physics does not remove significance. It removes centrality. You are no longer standing at the edge of creation. You are standing somewhere within it. This shift feels threatening because it reframes your relationship to time. You are not moving forward through an unfolding world. You are navigating a structure that does not respond to your sense of progression. The discomfort intensifies because this idea resists emotional resolution. There is no moment where it suddenly feels intuitive, no analogy that fully restores comfort. It sits quietly, undermining assumptions without drama, and that is precisely why it is effective. If the block universe were obviously absurd, it could be dismissed. Instead, it emerges naturally from theories that work, from equations that predict reality with extraordinary precision. The discomfort is the cost of consistency. You are not disturbed because the idea is incoherent. You are disturbed because it might be coherent, because it explains why time feels like it passes without requiring time to actually pass, because it explains why the present feels special without making it fundamental, because it explains why the future feels open while remaining real. The collision you feel is between how you must experience the world and how the world may be structured. You cannot live as if the future already exists. Your psychology will not allow it. You must plan, hope, fear, and decide as though the next moment is still undecided. This is not a flaw. It is a condition of being an embedded observer. Physics does not ask you to abandon this way of living. It simply refuses to mistake it for a description of reality itself. The unease you feel is the space between those two truths, and that space does not close. It remains, quietly reminding you that what feels most obvious about time may be the least fundamental thing about it. Every plan, fear, and hope you carry assumes an unfinished world. If the future exists, these mental states do not lose meaning, but they gain a different role. They are not shaping reality. They are revealing where you are within it. You plan because you believe the future is open. You fear because you believe something bad could still happen. You hope because you believe something better might come to be. These mental states feel forward-facing, as if they reach into an empty future and pull something into existence. If the future already exists, this picture changes, not in a dramatic way, but in a quiet one. Your plans do not stop working. Your fears do not dissolve. Your hopes do not become illusions. What changes is what they are doing. They are no longer engines creating reality. They are signals indicating your position, your knowledge, and your limitations within a structure that already contains outcomes. A map does not create the terrain. It tells you where you are. In the same way, your plans and fears may be best understood as orientation tools. They do not carve new paths into existence. They help you navigate paths that already exist but are hidden from you. From within experience, this distinction is invisible. Planning still feels like agency. Fear still feels urgent. Hope still feels motivating. Nothing about your inner life suddenly collapses when the future is treated as real. What collapses is the assumption that these states are pushing reality forward. Instead, they become diagnostic. Fear reveals uncertainty. Hope reveals preference. Planning reveals ignorance combined with intent. These are not flaws. They are adaptive responses to limited access. You do not plan because the future is empty. You plan because you do not know which part of the future you occupy. This reframing removes a subtle pressure, the pressure to believe that every thought is shaping the universe moment by moment, that every failure is a missed chance to generate a different reality. That meaning depends on the future being undecided in a literal sense. If the future exists, meaning does not vanish. It relocates. Meaning stops being about creation and becomes about alignment. Your values matter not because they summon outcomes into existence, but because they are part of the structure that leads to certain outcomes rather than others. Your efforts matter because they are the mechanisms through which particular regions of spacetime are realized along your world line. You are not shouting into the void of the future. You are moving through a landscape that responds to who you are. This also changes how regret and anxiety appear. Regret often assumes that the past could have been overwritten by a better choice. Anxiety assumes the future could still be ruined by the wrong one. In a block universe, neither of these involves rewriting reality. They involve understanding relationships between states. Regret reflects awareness of alternative paths that exist elsewhere in the structure, but are not yours. Anxiety reflects awareness of possible futures that exist, but are not yet accessible to you. These emotions do not indicate openness. They indicate contrast. You compare where you are to where you might have been or might be. That comparison is meaningful, even if all those places already exist. Nothing about this removes responsibility. It reframes it. Responsibility no longer means shaping an empty future. It means being the kind of system whose actions lead to certain outcomes within a fixed structure. You are responsible because you are part of the causal architecture, not because reality waits for your permission to exist. This perspective is unsettling because it removes the feeling of cosmic authorship. You are not co-writing the universe in real time, but it also removes a quieter burden. The burden of believing that meaning depends on an unfinished world. If meaning required the future to be unreal, it would be fragile. It would vanish the moment physics described reality more completely. Instead, meaning survives because it was never about creation in the first place. It was about position, perspective, and participation. Your hopes do not fail if the future exists. They become expressions of where you are and what you value. Your fears do not become irrational. They become indicators of uncertainty and vulnerability. Your plans do not become pointless. They become the way a finite system navigates an infinite structure. What changes is not what you feel. What changes is what those feelings mean. They are no longer evidence that reality is unfinished. They are evidence that you are embedded. And once you see that, the future stops feeling like something you are waiting for. It starts feeling like somewhere you are going. You navigate space using maps. Physics may be telling you that time works the same way. You are not traveling through it. You are located within it, experiencing only a narrow path. You are accustomed to thinking of time as a road you move along. Yesterday behind you, tomorrow ahead. The present feels like the place your feet touch the ground. This metaphor feels so natural that it rarely feels like a metaphor at all. Physics quietly replaces it with another. In the physical description of the universe, time behaves less like a road and more like a map. A map does not move. It does not unfold as you walk. It contains all locations at once. Your experience of movement comes from tracing a path across it, not from the map changing beneath you. Spacetime functions the same way. Events are not waiting to happen in sequence. They are already positioned within a four-dimensional structure. Your life is a line drawn through that structure, a world line that connects one event to another. From within that line, you experience direction, anticipation, and memory. From outside it, there is no journey taking place, only location. This shift in perspective explains why so many intuitions about time fail under physical scrutiny. You keep looking for motion because you assume time must behave like a process. Physics keeps offering structure because it does not require process at all. A map does not tell you where you will go next. It tells you where things are. Likewise, spacetime does not announce the future, it contains it. Your lack of knowledge about what lies ahead does not imply absence, it implies limited access. This reframing also clarifies why time feels personal. Two people standing in different places on a map will describe the terrain differently. Their experience depends on where they are and where they have been. The map itself does not privilege either perspective. Time works the same way. Your present is not the present, it is your present. You are not at the edge of the map where new territory is being drawn. You are somewhere inside it, with regions behind you that you remember, and regions ahead of you that you cannot yet see. The sense of traveling comes from how information arrives along your path. As you move through space, new sights come into view. As you move along your world line, new experiences become accessible. In neither case does the terrain itself need to change. Only your relationship to it does. This comparison feels unsettling because journeys feel active and maps feel passive. You want time to be something you do, not something you are embedded within. But physics is indifferent to this preference. The map view does not deny experience. It explains its limits. You do not experience all of space at once because your senses are local. You do not experience all of time at once for the same reason. Your awareness samples reality along a narrow corridor defined by physical constraints. That sampling creates the illusion of progression. Nothing in this picture requires time to move. It requires only that you do. This also reframes the idea of arrival. In a journey, you arrive somewhere that did not exist for you before. On a map, arrival is just relocation. The destination existed long before you reached it. The future may be similar. You do not arrive at the future because it comes into being. You arrive because you change location within space-time. The moment you call tomorrow was always there. You simply were not. This does not reduce significance. It shifts it. Meaning does not come from bringing something into existence. It comes from where you are within what already exists. A map can be vast without being empty. A landscape can be complete without being predictable. The fact that it is all there does not make your path through it irrelevant. It makes it specific. Time as a map removes the drama of unfolding, but it replaces it with orientation. You are not watching reality being written. You are discovering where you are. And once this perspective takes hold, a final intuition begins to weaken. If time is not a journey, then the urgency you feel may not come from the universe moving forward. It may come from the fact that you only ever experience one route through a terrain that contains infinitely many others. The block universe is not popular because it is comforting. It persists because attempts to remove it tend to break successful theories. Reality appears indifferent to how you wish time behaved. You might expect an idea this unsettling to fade away, to be replaced by something more intuitive, something that restores flow, restores becoming, restores a privileged now. And yet, again and again, physics returns to the same picture. Not because physicists prefer it, because alternatives fail. Every time a theory tries to reinsert a universal present, a flowing time, or a special moment where reality updates, it runs into trouble. Predictions stop matching experiments. Mathematical consistency fractures. Symmetries break without justification. The theory becomes heavier, more complex, less explanatory. The block universe survives because it is what remains when unnecessary assumptions are stripped away. Physics progresses by removing what cannot be measured, not by preserving what feels natural. Absolute space was removed. Absolute simultaneity was removed. Absolute time followed the same path. Each removal felt counterintuitive. Each one made the theory stronger. The block universe is not an extra hypothesis added for philosophical reasons. It is what is left when time is treated consistently across successful frameworks. Whenever physicists attempt to describe time as something that flows, they must add new structures to the theory. A preferred frame, a cosmic clock, a mechanism that selects a present moment. These additions do not improve predictions. They complicate them. Worse, they contradict evidence. Relativity refuses a universal now. Quantum mechanics refuses a single, well-defined temporal order. Thermodynamics explains direction without requiring motion. Field theories work without a moving present. Gravity does not care which moment you call now. Across domains, the same pattern repeats. Theories that assume time flows struggle to explain why the laws themselves do not reflect that flow. Theories that treat time as a dimension explain more with less. This is why the block universe keeps returning, not because it answers every question, but because it avoids creating new ones. It does not claim to explain experience directly. It explains structure. Experience is then understood as something that arises within that structure, not something that defines it. This separation is uncomfortable because you want your experience to be central. You want the world to be organized around how it feels to exist. Physics does not grant that privilege. Reality appears indifferent to your intuitions. This indifference is not hostility. It is neutrality. The universe does not seem to care whether time feels like a flow, a sequence, or a story. It behaves in ways that are consistent, measurable, and mathematically coherent. When those behaviors are taken seriously, the idea of a completed spacetime emerges naturally. You can reject it. Many do. But rejecting it usually requires adding assumptions that have no experimental support. A preferred now that no instrument can detect. A flow that leaves no trace in the equations. A becoming that affects nothing measurable. Physics has learned to distrust such additions. The persistence of the block universe is a reminder of how science actually works. Ideas do not survive because they feel right. They survive because they fail to be eliminated. Every time time is treated as something that moves, the theory demands extra structure to explain why motion leaves no physical signature. Every time time is treated as static, those demands disappear. This does not prove the block universe is true in some ultimate sense. Physics rarely proves anything that way. But it does explain why the idea refuses to go away. It is not an interpretation layered on top of the math. It is what the math quietly implies when taken at face value. The unsettling part is not that physicists keep proposing this view. It is that nature keeps allowing it. The universe does not correct the equations when they describe a static spacetime. It does not produce anomalies. It does not signal discomfort. It behaves exactly as predicted. This suggests a difficult conclusion. The resistance to the block universe does not come from evidence. It comes from expectation, from a mismatch between how reality feels and how it appears to be structured. Physics has faced this mismatch before. Each time, intuition lost. And that is why this view keeps returning. Not because anyone wants it to, but because reality keeps tolerating it. From relativity to quantum theory, independent lines of evidence converge on the same implication. Time does not flow. Moments do not come into existence. They are already part of the structure you inhabit. What makes this idea difficult to dismiss is not any single experiment or equation. It is the convergence. Different theories, built for different reasons, using different assumptions, aimed at explaining different phenomena, arrive at the same conclusion without coordinating with one another. This is not coincidence. Relativity treats time as a dimension. It removes a universal present and replaces it with observer-dependent slices of spacetime. Quantum theory undermines fixed temporal order and allows correlations that do not respect a simple before and after narrative. Thermodynamics explains direction without motion. Field theories describe entire histories rather than evolving moments. Each theory could have failed in a different way. Instead, they quietly agree. No major framework in modern physics requires time to flow. None demands that moments are created as the universe advances. None contains a mechanism by which the present sweeps forward, turning possibility into reality. And crucially, experiments do not demand one. This agreement is not dramatic. It is almost disappointing in how uneventful it is. There is no single test where physicists announce that time has been proven static. There is no decisive moment. There is only the steady absence of any evidence that time does what you feel it does. Again and again, equations that treat time as static make correct predictions. Again and again, attempts to introduce temporal flow add nothing measurable. The silence is the signal. When mathematics describes a universe where all moments coexist and experiments fail to contradict that description, the burden shifts. It is no longer on physics to explain why time does not flow. It is on intuition to explain why it feels like it does. This is uncomfortable because intuition is persuasive. You live inside it. You trust it. It feels more immediate than equations written on a page. But immediacy is not reliability. Math does not care how something feels. It cares how structures relate. Experiment does not care what seems obvious. It cares what can be measured. Together they form a filter that removes what cannot survive contact with reality. Temporal flow has not survived that filter. What remains is a picture of the universe that is complete, not in the sense of being understood, but in the sense of being fully there. Past, present, and future are not stages. They are regions. You occupy one of them. You remember others. You anticipate others. But none of that changes their existence. This quiet agreement does not tell you how to live. It does not tell you how to feel. It does not tell you whether this picture is comforting or horrifying. It simply tells you what the most successful descriptions of reality have in common. They do not privilege now. They do not model becoming. They do not require time to move. The unsettling power of this convergence lies in its restraint. Physics is not shouting that time is an illusion. It is whispering that time may not behave the way you think, and then refusing to contradict itself. If this picture were wrong, you would expect cracks to appear, inconsistencies, experimental failures, mathematical contradictions. Instead, the theories reinforce one another. Relativity fits neatly with a block universe. Quantum mechanics refuses to rescue flow. Statistical mechanics explains asymmetry without motion. Each piece slots into place. This does not mean physics has finished explaining time. Far from it. But it does mean that whatever time ultimately is, it is unlikely to be a river carrying reality forward. The agreement between math and experiment does not resolve the paradox. It deepens it. Because once you see that time does not need to flow for the universe to function, the question shifts again. If moments do not come into existence, if the future is already part of the structure, and if the present is not fundamental, then the most basic feature of your experience is not mirrored by reality. And that leaves you facing a quiet, persistent tension. You live as though time is happening. The universe behaves as though it is not. Both appear to be true, and physics offers no easy way to reconcile them. If the future already exists, then your sense of anticipation, regret, and urgency is not a response to an unfolding universe. It is a response to your position within a fixed one. And the question that remains is not whether this is true, but what it means to live inside it. You reach a point where the physics stops arguing and simply stands there. The equations do not flinch. The experiments do not object. The structure holds. What remains unsettled is not the universe, but you. If the future exists, then anticipation is no longer a reaction to emptiness ahead. It is a reaction to ignorance. You feel urgency not because reality is rushing forward, but because your access to it is limited. You are standing at a location where information has not yet arrived, and your mind fills that gap with expectation. Regret changes as well. You regret past choices because you imagine they could have rewritten what followed. In a fixed space-time, regret is not about missed opportunities to change reality. It is about recognizing alternative paths that exist elsewhere in the structure but are not yours. The pain comes from contrast, not from causation. Urgency, too, takes on a different shape. You feel pressure to act now because now feels like the only place where action is possible. But if all moments exist, then action is not confined to a privileged present. It is confined to your location. You act here because here is where you are, not because reality is waiting. This reframing does not dissolve emotion. It deepens it. Anticipation becomes awareness of distance rather than creation. Regret becomes recognition rather than failure. Urgency becomes locality rather than cosmic importance. None of these lose their force. They lose only the assumption that the universe depends on them to move forward. The remaining question is not abstract. It is personal. How do you live in a universe that is complete? You cannot live as though the future is already known. You cannot act as though anticipation is meaningless. You cannot stop planning, hoping, fearing, or deciding. Your psychology does not allow it. You are built to operate under uncertainty, even if that uncertainty is not fundamental, and physics does not ask you to change that. The block universe does not require you to feel differently. It requires you to understand differently. It suggests that your experience of time is not a guide to what exists, but a guide to where you are. That your emotions are not responses to cosmic events coming into being, but to your position within a structure too large to perceive all at once. This leaves you in an unusual position. You must live as though the future is open, while understanding that openness may be experiential rather than ontological. You must act as though your choices matter, while accepting that they are part of a structure that does not wait for you to make them. There is no contradiction here, only tension. A tension between how reality may be structured and how embedded observers must experience it. You cannot step outside that tension. You cannot resolve it with insight or acceptance. It is not a puzzle to be solved. It is a condition. You are an entity that experiences sequence inside a universe that may not sequence itself. You are a system that feels movement inside a structure that may be still. You are a perspective that lives at the edge of information, mistaking that edge for the edge of existence. The question that remains is not whether the future exists. It is how to carry meaning, responsibility, and attention in a world where existence does not wait for you to arrive. Physics does not answer that question. It leaves it where it belongs, with you. Standing inside a universe that may already be complete, still feeling as though something important is about to happen, unable to stop acting as if it matters, because from where you are, it does, and that may be the only place meaning was ever possible.